Alright, hey guys. This is chapter 11, chapter 10 rather, section 6, dealing with circles and arcs. It's a very definition heavy section, and it has a proportion that you're not really going to like too much, but we'll do the best that we can. So it starts off with certain definitions that you already know, namely a circle. And they say that a circle is a set of all points that are equidistant from the center. We know that when we have a circle, we have a line that cuts it completely in half or goes straight across the circle. That line is called the diameter, or D for diameter. We also have with our circle, from the center for our circle out, that's our radius. And the radius is always going to be equal to half the diameter. So the diameter goes completely across, and then the radius goes halfway across. So it comes out from the center. Those are things that you guys should already know, I hope. Then we have something called the central angle. So if we have a circle, we have a point, we have two radiuses that emanates out from that point. This angle, since it comes from the center of the circle, is called the central angle. The central angle, and it's the central angle because it comes from the center of the circle. If we have two circles that have the same radius, if we have two circles and they have the same radius, so the radius of the first circle is equal to radius of the second circle, then we can say that these two circles are congruent. These two circles are congruent because the radius are the same. So the circles are the same size and the circle are the same shape. When we cut a circle in half, we call that, this part all in here, that's a semicircle. And remember, a semicircle just means that we cut it in half. Semi means half. So semicircle is half of a circle. We have things called minor and major arcs. So we have this circle. We have point P. And then we have this point R. I guess uppercase R. Point S. And then point T. So a whole circle, completely round, is 360 degrees, right? A semicircle is 180 degrees. It's just half, right? Half of 360. So when we have arcs, and arcs is going to be the distance, part of the distance of the circle, or part of a circle. If the arc is greater than 180 degrees, so let's say this RS, and we put the little arc symbol on top, the little curve, meaning that's arc. This would be a minor arc. And it's a minor arc because it's less than 180 degrees. Less than 180 degrees. So we call that a minor arc. And notice that it has two letters, the R and the S, right? So this would be my minor arc, RS. Now, what if we had an arc bigger than 180 degrees, bigger than half a circle? So let's go this guy. all the way around here. We would call that arc STR. And we would call that a major arc. And it's a major arc because it's greater than 180 degrees. So then that is a major arc. And we call STR, we call it with 3 letters. Notice that a minor arc has 2 letters, RS, and the major arc has 3 letters, STR. That's important. Alright. Naming arcs. So we have this circle over here. They want to know what the minor arcs are in A. So if I have this circle here, we can say that a minor arc is they are PQ. That's a minor arc. PS, SR, and we can say that RQ. These are all minor arcs, and they're minor arcs because all of those arcs, all those parts of the circle, are less than 180 degrees. Then they want to know what the semicircle is. The semicircle, remember a semicircle means it cuts it in half where it's 180 degrees. So the only thing that cuts it completely in half is RP. So RP would be my semicircle. Then they want to find major arcs. Remember, major arcs are greater than 180 degrees. I see Q, P, R. That's a major arc. S, R, Q. Is a major arc. And PRS, I would say, is a major arc. Notice that the major arcs are greater than 180 degrees, and they're 3 letters. Semicircle we can say is 2 letters. I've seen it with 3, it doesn't matter. And minor arcs are 2 letters. That we put the little curve on top. So we can do our arcs. Arcs are measured in degrees, and we can say that the arcs are equivalent to the central angle. So these guys are measured in degrees. So they want us to find, so here's a circle. Angle RST is the central angle. This only works, guys, when you have a central angle. And the central angle in this case is angle RST, and that's 50 degrees. Well, the arc length, which is RT, is a minor arc. And it's a minor arc RT. And that's going to be equal to the central angle. So the minor arc, or any arc, is equal to the central angle. So since RST is 50 degrees, the minor arc RT is the same, so they're both 50 degrees. If you wanted to find the arc for anything, you can always just subtract that arc by 360. Alright, arc addition postulate, that just means that if I have arc AB and arc BC, so this guy and this guy, if I wanted to know what they are in terms of the length, I can just add them together. I can add or subtract arcs from each other. Okay, so for this one, we have this circle C. It has a 77 degrees. Let's see if I can draw this one. Okay. Q, S, R, P, 77. And then when it's on the inside, it's talking about the central angle. When it's on the outside, it's talking about the minor or major arc. So they want to know what PR is. Well, the measurement of PR is the same as the central angle, so that's going to be 77 degrees. They want to know what RS is, so this is RS. Notice that PS is a straight line that cuts it completely in half. So PS is a semicircle. Since PS is a semicircle, I know that a semicircle is 180 degrees. I know that a semicircle is 180 degrees. So in order to find RS, I can just subtract PS which is minus PR. Keep doing that. Which is going to be 180 minus 77, which gives me 103. So RS is 103 degrees. Okay. So RS is 103 degrees. So measurement of PRQ. So P, R, and Q. If I wanted to find that, I'm just going to add these three up together. So 77 plus 103 plus 28. So the measurement of PRQ is going to be 77 plus 103 plus 28. Or you could say 180 plus 28, which is 208 degrees. And then PQR, again, if you want to think of this as semicircle PS, this whole thing is 180, right? So P to S is 180, so then 180 plus the R, which is 103. So the measure of PQR is equal to 180 plus 103, which is 283 degrees. Okay. We have a circle. We have a line that cuts it completely in half. We have another circle coming from the center and out. We know that this is the radius. We know that this is the diameter. Circumference is the distance around the circle. And when you have the diameter, the circumference is equal to pi times the diameter. And when you have the radius, circumference is equal to 2 pi r, or 2 times the radius. The book says you can use the pi symbol, you can use 3.14, and the one that's never hardly used, 22/7. I don't even know why they even tell you to use that silliness. Concentric circles. So we have a circle within a circle. It's not to scale. They have the same center. And if they have the same center, then they're called concentric circles. Concentric circles. Circles that share the same center. Alright, so when trying to find circumferences, you can answer questions in terms of pi, or you can answer questions in terms if they ask you for feet in decimal form. Most cases it's going to be in pi. So in the case of this problem here, we have a guy that's standing in the center. I guess it's a television camera around a track. The track is 2 feet long, and the center from the outer edge, and then the guy is 8 feet from the track. So I guess they want to know the differences and the differences. What do they want? They want to find. Oh, they want to find the distance of the wheel. Okay, so you're going to do a subtraction. So you're going to use the circumference equation. So that's 2 pi r. The guy has a radius of 18. So we'll start with so we'll call it radius number 1. So radius number 1 is 18. And we'll say radius is number 2, which is the track, is 2. So to find the first circumference number 1, that's 2 pi r. So 2 pi, in this case it's 8. Which is 16 pi. That's circumference number 1. Circumference number 2, or the outer edge, it's going to be 2 pi 2, or 4 pi. If I add those two guys together, it's going to give me 20 pi, which is a whole circle. The way that the book did it was they added them together and subtracted the 16 pi to get to 4 pi. Or you could have just done the outer track, which was 4 pi. So the answer is 4 pi. They want you to convert it into feet without the pi. You just multiply 4 times pi, and I'll get you 12.6 feet. Uh, Down here is a similar problem. It says we have a circle. Car turning with a radius of 16.1, and then the distance between the front tires is 4.7. So we can have diameter number 1 is 16.1, and then diameter number 2, radius, I'm sorry. And then radius number 2 is 4.7. So circumference equals 2 pi r. So for radius number 1, or circumference number 1, that's going to be 2 pi 16.1, which is 32.2 pi. And then diameter or circumference number 2, 2 pi 4.7, which is 9.4 pi. So if I want to find out the difference, all I do is I subtract the two, and that should give me my distance. So they want to know how much the difference is on the outside of the tire. So this is the difference in my outside of the tire. So 9.4 pi is equal to 29.5, and it's going to be in feet. And that's it. Alright, the part you're not going to like. So we have something called, we talked about minor arcs and major arcs. Minor arcs and major arcs these guys are measured in degrees. Then we have something called arc length. So arc length is measured in units like feet, inches, meters. And the minor and major arcs and the arc length are the same. It's just measured in different ways. Measured in degrees versus measured in units. And you can set up a proportion. And this is how it works. Remember, a proportion is two fractions that are equal to each other. The first fraction, first of all, fraction is always going to be your part over the whole, right? Well, when we're talking about the minor arcs or the major arcs, right, we have a circle. Let's call it PQ, right? PQ is my minor arc. That's my part, all right? That's my part. And then the whole, if this is measured in degrees, then what's the degree of a whole circle? Well, the degree of a whole circle is 360 degrees, right? So our part over our whole, the part of the minor or major arc over the whole entire degree of the circle. And that's the first fraction. Then we have another fraction, which is called, they call it the length of, and we're going to use the same circle, they call it the length, right? And this is going to be the length of PQ, right? And if the whole circle, this is around a circle in degrees, is 360, then the whole circle measured in units is 2 pi r. They're the same. There's also the whole. The only difference is one is in degrees, 360 degrees, and one is the circumference, 2 pi r. Or you can also say pi d. So what we're going to do is we're going to set these two proportions equal to each other. So I'm going to call L for length. Length of PQ over 2 pi r is equal to the arc over 360 degrees. We're going to multiply both sides by 2 pi r. They cancel. So my length of PQ is equal to the measurement of PQ in degrees over 360 degrees times 2 pi r. And that's the equation that we get for the length, the actual measurement units of that same part of the circle. And we call that arc length. And that's theorem 1010. So, what's another radius 1.3? So if we do a question on this, if you look at number 4, they ask you to find the length, the radius of a semicircle with the radius of 1.3. So we have a semicircle, and it has a radius of 1.3. What do I know about a semicircle? It's 180 degrees. So when I set it up, the arc length is equal to the measurement in arcs in degrees. So I'm just going to put xy over 360 times 2 pi r. Alright, so since I know it's a semicircle, I know that it's 180 degrees over 360. 2 pi, I know the radius is 1.3. So when I do the math, it's 1/2 they want the answer in terms of pi. They said to leave your answer in terms of pi. So this is going to be 1/2 times 2 times 1.3 times pi. 2 times 1.3 cancels out. I'm just left with 1.3 pi. And this is going to be measured in meters. If I wanted to measure out the pi and not use it in terms of pi, it would be 4.1 approximately. Okay. So let's do these last few problems and then we will be done for today. For number 1 here we have this circle. They want us to find the name of a major arc. So We could do it in a couple of ways. The radius is why does the radius there? I know that CB is a semicircle, so I know that CB, arc CB, is 180 degrees. I can also add CD. Can't think today. Which is 65 degrees. So then I get a major arc of let's call it B A D. Haha, it's bad. Which is 180 plus 65, which is 245. So that's 1 minute. So that's number one. Oh, that's number two. My fault. And then the name of a minor arc, which is number one, we could just say CD, right? Which is 65 because it's less than 180 degrees. They ask you to name the semicircle. The semicircle we just said was CB. You can call it CB, or you can call it CAB. I've seen it done both ways. Most likely it's going to be the CAB, and that's equal to 180. They want to know the measurement of AB. Well, it's 81 degrees. That's their central angle. So the measurement of the arc is also 81 degrees. So the measurement of AB is equal to 81 degrees. They want to know the circumference of the circle. We have a radius of 9. So circumference is equal to 2 pi r. In this case, it's going to be 2 pi 9. So the radius is going to be 18 pi centimeters. If you want to multiply the pi through, 56.5 centimeters. They want to know the length, not the arc. They want to know the length of BD. So here's BD. Here's my semicircle. So I know that I can subtract 180 minus 65, and that's going to give me the measurement of arc BD, which is 115 degrees. So BD is 115 degrees. So in order for me to find the length of BD in units is equal to 115 degrees divided by 360 degrees times the circumference, which is 2 pi r. And we said that that was 18 pi from before. So 115 divided by 360 times pi times 18. I get that the length of BD is equal to 18.1 centimeters. 18.1 centimeters. Alright, guys. And that's how you find the length. Alright, so that's section 10.6. Have a great rest of your day.